Hey guys, I thought I'd do a quick video where we just go over the code for quicksort one more time. If you want to see me actually code it out and go into a little bit of the theory on how it works, watch the previous video, but this is just to go over the code one more time to kind of sink it in. But I'll be talking a little bit about how it works again, so don't worry about that. So we have only two functions, sort and partition, and the print list is just to print it out for us to see. The main's pretty simple, just make an array, print it out, sort it, print it out again. Let's get into the meat of it. Alright, let's dive straight in. Let's start with what we're doing. So we're going to put in our two indices, low and high. Okay? And as long as low is less than high, we know we have an array size of greater than one element, because a one element array is already sorted. No reason to deal with that anymore. So, but if it's greater than one, we still have to check it sorted. So we're going to partition the array that we have. Alright? Where before, where we had a pivot, and we wanted to imagine that he's going somewhere in the middle, and we're just going to switch guys that should be greater than, guys that are less than him should be on his left, and guys greater than him are to his right. We don't care about particular order, because at the end of the function, once we make sure that everybody has everybody to their left less than them, everybody to their right greater, we know it's sorted. That's the definition of being sorted. So we don't worry so much about the order right now. So we pick a pivot at the beginning of the array, and we call him a pivot, but really he's just a number that we're going to be, his value is what it's going to decide on whether we switch people. So it's the value we switch people around. So I picked the guy at the beginning of the array, and I think I still have paint open from the last lesson. Oh, I do. We pick a guy at the beginning of the array, and we're going to keep running down until we find somebody greater than him, because he should be on the other side of the array. And we're going to switch him. When we start from the other side, we're going to be coming down until we find somebody greater than, or less than him, and we just switch them, because we know if they shouldn't be in that order, so we're going to switch them. They may not be in the exact correct order, but that general order is what they should be in. Okay? So you see me here, just make a temp variable. We'll see what that is used for later. But we get my left part of the array that I'm partitioning, and the right part, low and high. And then the pivot's going to be our first guy in the array, the number that we're deciding to switch around. So we're going to keep running until we're done. So I'm just going to put a while one in here and put a condition to break. Like we talked about in the last video, as soon as I is running somewhere and stops, and then J passes him, we know that we've hit a point where all the guys that are less than him or greater than him are on the right, and the guys that are less than him are all on the left of each other. That's good. They're not in exact order, but that's the general order that we want. So we're going to stop. And now where J stops is always at the very end of the guys all less than him. So if I just take the pivot and put them in right there, and I throw whoever it was to the back, they're not in the exact right order, but I still have everybody less than him to the left, and everybody greater than him to the right. So I can be 100% sure that that guy is now in his proper spot. The rest of the array is not sorted at all, whatsoever, not even close. But I know that that guy is perfect. So that's what we're going to do. We're going to say while num's left is less than or equal to the pivot, because we start right on the pivot, so we're going to say less than or equal to. And he hasn't reached the end, we're going to keep incrementing it. Okay? And then so once we stop somewhere, we go on to the next guy. So right, now we're going down. So as long as we're greater than the pivot, keep going. We're trying to find someone less than him. Okay? Once we've found those, we're going to check. Is less than right? Well, if he is, we're going to break out. And we're going to switch him. We're going to switch the guy where J is, because he's at the end of everybody less than him, or I call it right in this case, because most people call it I and J. I just like to call it left and right, because I remember which side they're coming from. I'm going to switch him with the pivot right here. You see me store him in temp, and then just over right, and then over right left, which whatever temp was. Pretty straightforward. Or you see me do it down here. In here, though, if left is not less than right, or I mean if left is not greater than right, so if I is not past J, the guy over here is not past this guy, I may have said the opposite earlier, then we're just going to, if they're like this guy's coming up, stops, guy's coming up, stops, we're just going to switch them. And that's what we do here. We just switch left and right. Okay? And so once we get that, and then we're going to return the value of that guy that's sorted perfect, because we want to exclude him from all future calculations, because he is perfect. So what I'll do is I will now make a smaller little range of all of the array that's to his left, and I will sort it, as you see here. And then I will make a small range of everything to his right by going 1 to his right. and sort it here. And this will continue down and down and down and down and down until I get to little like 2 bite-sized arrays where I just swap them the right way, and I come back up, 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 and we know that everybody has to their left, everybody less than them, everybody to the right is greater than them, which is the definition of being sorted. Now if I run it one more time, boom, we get a perfectly sorted array. See, I just got to read the numbers to make sure there's no bugs. We get a perfectly sorted array. Okay, great. So just a quick little review of it. I hope that was helpful to you guys. I will see you next time.